The first speaker of the evening is Dr. Peter Adesina. And to get us started, he will join us from the University of Toronto. Dr. Adesina holds a PhD in geotechnical engineering from Imperial College of London. He has held research positions at the University of Bath, UK, INRAE in France, and the University of British Columbia, as well as the University of Toronto. His research integrates advanced laboratory and numerical methods, including high-performance computing to characterize soils and mitigate failure in civil infrastructure. Please welcome Dr. Peter Adesina.
Hello, everyone. I have a quick question for you. How many persons here, by show of hands, have used a phone, a computer, or any modern technology before? Okay, great. Pretty much everyone. Now, all of these modern technologies that we've all used at one point or the other in our lives are made from minerals that are mined from the ground. When we perform mining, we generate waste that we call tailings. Tailings we store in what we refer to as tailing dams. My name is Peter Adesina, and what I'd like to share with you today is my contribution to the delivery of resilient dams and communities by mitigating a failure mechanism which we call liquefaction in tailing dams. So in the last decade, we've had major tailing dams failures around the world, including here in Canada. In Canada, we had the incident in Alberta and the one in British Columbia, both of which had huge impact on the communities living downstream. Outside of Canada, we had the Brumadinho Dam disaster that occurred in Brazil, which killed over 250 people in one instance. So 2,650 people have been killed by tailing dams failures around the world. 317,000 more have been displaced. We have about 500 tailing dams in Canada, almost half of which we have here in Ontario. Canada's mining activities is going to increase. Why? Because we need lots and lots of rare earth minerals for defense equipment manufacturing and also for the development of modern technologies. And in fact, Canada is taking the lead in the defense equipment manufacturing to reduce her reliance on our southern neighbor. And so with more mining activities in Canada, that means that we would have more of these failures in the future. So tailing dams failures are caused by different mechanisms, chief of which is liquefaction. So what is liquefaction? Imagine that you have a stable soil and you subject it to shaking, let's say from an earthquake. If you shake the soil well enough, it's going to begin to flow like a liquid. This is what we call liquefaction. What happens in a liquefaction scenario is that the soil goes from a state where the particles have contacts to one where contacts are lost. And this is because of increase in water pressure within the soil. So we can have earthquake-induced liquefaction, and in Canada we have about 4,000 earthquakes occurring per year, which means we have huge potential for earthquake-induced liquefaction in the country. Hopefully one doesn't happen as we are here. We also have another kind of liquefaction that we call static-induced liquefaction. This is caused by the self-weight of a dam. It is actually the one that killed over 250 people in one instance in Brazil. So the essence of my research is to prevent and mitigate liquefaction in dams. And I do this by assessing whether the soil in a dam is susceptible to liquefaction or not, using what we call the cone penetration test. So I have another quick question. How many persons here have taken an injection before? I mean, from a doctor. Okay, so cone penetration test, we can liken it to pushing an injection syringe within a soil. But this syringe, though, has sensors within it that can help us obtain parameters that can give us an indication of the state of the soil within a dam. So we can perform cone penetration test in situ, but it is expensive and difficult on the field. It is the reason why we perform cone penetration tests within a calibration chamber that we have within the lab, where we have control over influencing factors. So when you push a cone within a soil, you obtain the resistance of the soil against the push of the cone, and we call this the cone tip resistance. We then plot this tip resistance against a measure of the density of the soil. So if the soil is dense, we have high resistance, and if the soil is loose, we have low resistance. If the soil in a dam falls in the region that indicates that the soil is loose, we can conclude that this dam is susceptible to liquefaction. So with my research, we can assess liquefaction susceptibility in tailing dams to prevent failures. This enables us to protect communities living downstream of tailing dams, thereby preventing their untimely deaths. And this means you and I can use our phones, our computers, all of our modern technologies with less blood on our hands. Thank you.